Normalization. Lessons 2.1. Basic concept of normalization. In this lesson, the basic concept of functional dependencies will be explained, and the basic concept of normalization will be explained. Functional dependencies are used to specify formal measures of the goodness of relational design. Functional dependency and keys are used to define normal forms for relations. Functional dependency are constraints that are derived from the meaning and interrelationships of the data attributes. A set of attributes X functionally determines a set of attribute Y if the value of X determines a unique value for Y. X functionally determines Y holds if whenever two tuples have the same value for X, they must have the same value for Y. X functionally determines Y in R, specifies a constraint on all relation instances. Functionally dependencies are derived from the real-world constraints on the attributes. There are the examples of functionally dependency constraints. Social Security number determines employee name. Project number determines project name and location. Employee Social Security number and project number determines the hours per week that the employee work on the project. A functional dependency is a property of the attributes in the schema R. The constraint must hold on every relation instance. If K is the key of R, then K functionally determines all attributes in R. Then I will talk about the inference rules for functional dependencies. Given a set of functional dependencies F, we can infer additional functional dependencies that hold whenever the functional dependencies in F hold. Armstrong's inference rules. A1. Reflexive. If B subset of A, then A functionally determines B. A2. Augmentation. If A functionally determines B, then AC functionally determines BC. The notation AC stands for A subset of C. A3. Transitive. If A functionally determines B, and B functionally determines C, then A functionally determines C. A1, A2, A3 form a sound and complete set of inference rules. There are some additional useful inference rules. Decomposition. If A functionally determines BC, then A functionally determines B, and A functionally determines C. Boolean. If A functionally determines B and A functionally determines C, then A functionally determines BC. Pseudo-transitivities. If A functionally determines B and DB functionally determines C, then DA functionally determines C. Closure of a set F of functionally dependencies is the set F plus of all functionally dependencies that can be inferred from F. Normalization is the process of decomposing unsatisfactory bad relations by breaking up their attributes into smaller relations. So why we have to normalize? For feasibility, structure supports many ways to look at the data. For data integrity, it helps modification anomalies, including deletion, insertion, and update. For efficiency, it eliminates redundant data and saves space. Normalization is used to eliminate one of the data anomalies, data duplication. Without normalization, it is difficult to handle and update the database because of data duplication. Insertion, updation, and deletion anomalies are very frequent on the database. Take updating anomaly as an example. In this table, there is a student Adam who occurs twice or more than twice in a table. If we have to update the address of Adam, we need to update student address column in all the rows to avoid inconsistent data. For insertion anomalies, when there is a new admission, we need to insert new data. We have a student ID, name, and address of a student. But if student has not opted for any subjects yet, then we have to insert null there, leading to insertion anomaly. For deletion anomaly, if student ID 401 has only one subject and temporarily he dropped it, when we delete that row, entire student record will be deleted along with it. The normal forms is a series of logical steps to take to normalize data tables, including first normal form, second normal form, third normal form, box-scoped normal form. There's more, but beyond scope of this class. We can certify whether a relation schema is in a particular normal form based on keys and functional dependencies of a relation schema. I will then talk about some terms relating to functional dependencies and normal forms. You will see this term in the future class frequently. Single value attributes mean non-key attributes the values of which are uniquely identified by the value of the primary key. In this example, student name is single value attribute because each student have only one student ID. Multi-valued attributes or repeating groups means non-key attributes or groups of non-key attributes, the values of which are not uniquely identified by the value of the primary key. In this example, course ID is multi-valued attribute because students can study many different courses. Partial dependency occurs when a non-key attribute is determined by a part but not the whole of a composite primary key. In this example, customer ID and order ID are the primary keys in the table customer, and name only depends on one of the primary keys, customer ID. Therefore, name is partially dependent on the primary key. Transitive dependency occurs when a non-key attribute determines another non-key attribute. If A functionally determines B and B functionally determines C, then A functionally determines C. A functionally determines C is transitive dependency. In this example, employee ID functionally determines department ID, and department ID functionally determines department name. Employee ID functionally determines department name is transitive dependency. That's the end of the lesson. Thank you.